Okay, guys, in this video, we are going to start talking about testing hypothesis for the population mean. Okay, so what are the steps? So number one, we are going to have to decide what is the purpose of the test. So read the question and focus on the main point of the research. What is it that they wanted to do? And based on that, you're going to decide if the test is two-tailed, left-tailed, or right-tailed. Then you're going to decide the null hypothesis. So notice the structure of the null hypothesis. It's always going to be equal sign in the null hypothesis, and it's always going to be equal to some number. So this number, this mu0, should never, ever, ever come from the sample. So this should be something that we thought was true in the past, and now maybe something else changed. Or we think that the prices in the past were for eggs were $6, but now they're less, or something like that. So the 6 is your mu0, okay? And then the alternative hypothesis, depending on the claim, the only choices you've got are either not equal. So if they just said, we want to know whether the price has changed or is different today. So look for those clue words in the claim, different, changed. Or they will say something like increased is higher now, so that means that it's going to be greater. And if it said decreased, less, whatever, then that would be less. So that would be a left-tail test. Okay, so once we do that, we're going to use technology. You're going to use Desmos to find something called the test statistic. Now you can think of a test statistic as a t-score. Well, it's like a z-score, but now because it's t-distribution, it's t-score. The larger this number is, the more opportunity to reject. Okay, so the larger, the weirder the situation, which will contradict the null hypothesis, and we're going to reject the null hypothesis. Now, the p-value will also be provided, and it depends on the test statistic directly. The larger the test statistic, the smaller the p-value, and the smaller the p-value, the more unusual situation is, and then you decide reject or not. Okay, so let's look at a couple of examples. And of course, this should also be on your cards. If it's less than alpha, unusual, we reject. If the p-value is greater than alpha or equal, do not reject because it's not unusual. Okay, so let's look at the first example. This is going to be just a summary, and then I'm going to look at one more example with data. Okay, so in this case, we are dealing with something called the credit score of a person. And this basically tells you how credit worthy you are. So if your credit score is large, then it'll be easier to get a loan. But if your credit score is not so good, because maybe you have no credit or your credit is bad, you didn't pay your past loans, then it's going to be lower. But what they wanted to test is the most important thing you should focus on. Okay, see how it says, a credit analyst wondered whether the high income individuals had higher credit scores. So the moment you see that that's the claim, right? Because they always say, we want to know that, or he wondered that it has higher credit scores, that will be your alternative hypothesis. So it's going to be the more than. It's going to be a right tail test. Okay, so now what's what here? So first of all, you're looking for the value of mu0, which is the null value of the population mean. So what is it? See how here on the bottom they give you some sample stuff, like sample statistics, sample mean, sample standard deviation. They also tell you how many observations in the sample. Mu0 should never, ever, ever come from the sample. It is always something that we had before, okay? So look at this number right here. So you can see that this number right here, that's your mu0. Do not look for mu0 in the sample. What is in the sample? Well, in the sample, you've got the n, which is the sample size. You've got the sample mean, which is x bar. Hopefully you know that. And the sample standard deviation, which is s. So that's the sample stuff. Okay, so based on that, let me show you what to put in Desmos. So we're going to click on the plus sign. We're going to go to the inference menu. In the inference menu, you have only two choices for this test, for this next test that you're going to be taking. It's either going to be the t-test if you are using, if you are doing the confidence interval or the test of hypothesis for the mean, or it's going to be proportion, which is going to be, again, either confidence interval or test. Because this is the mean, you're going to use t-test. All right, how do you know it's the mean? Because the word mean is everywhere. Now, are we going to have data or stats? Well, in this case, we got stats because we have summary stats. We don't actually have the data. So it's asking us what's the sample size? That's 40. Sample mean is 714.2. Standard deviation 83.2. That's it. So now we just click create test. And this time, remember we did this for for confidence interval. Now we're doing significance test. So open that. Now decide which tail you got, left, both, right. You can see that the claim said higher. By the way, the words, the clue words, you're only looking for them in the claim. So don't look for them in the whole question. You just want to focus what is it that they wanted to test. Okay, because sometimes people see some other word in there and they're like, oh, it's low, so it's probably going to be less. Only if it's in the claim, in the sentence that has a claim. So because it says higher, it's right. Okay, but it's still not done because there is something else that you have to pay attention to. What is this something else? This right here. That is supposed to be mu0, and this should never, ever, ever, ever be left as 0 because that will give you very weird and wrong results. You are not testing that the mean is 0. What was your null value, that mu0? This one, 703.5. Okay, that's it. And once you fill that out, so this, all of that, that comes from the sample, and this is your mu0. Now you can just read, if you click on the three dots, you can see the t-score or the test statistic. And if you need to, you can export it, and then the p-value is right here. So 0.2105 approximately. So what are we gonna do with our alpha? We're just gonna subtract and say, okay, is p-value less than alpha? Then we reject the null hypothesis. No, that didn't happen here. We got a positive answer, so we are not going to reject. So what is going to be our conclusion? Well, because p-value is more than alpha, we are not rejecting. And notice how if you do not reject, then you will not have evidence. So that's the important part. So here do not, and the other one is do not. What do we put in the after the word conclude? That has to mirror the claim. Remember, the claim said that individuals with high income, whatever, had higher mean score. So remember that higher word, that has to be here. In the conclusion should always mirror the claim. Okay, let's look at one more example. This one is going to be with data. So this example has data on monthly cell phone bills, and they just want to know whether they are different. So notice the clue word. We want to know if they're different, which means that this is going to be a two-tailed test. But this time, unfortunately, guys, you guys are going to have to possibly also check assumptions. In the previous case, by the way, because your sample size was 40, that's more than 30 and you don't have to worry about it. But this particular case is 12. Now, because we already did this for confidence intervals, I am not going to spend much time on it. So I'm just going to show you. I have the normal probability plot here, and you should remember what to do here. And if you do not, go back to that video and rewatch it for lesson 15, the first video. This is where we had to take the correlation, and then we compared that with the critical value. And we said that if the critical value or the correlation rather is larger than critical value, that means the assumptions are satisfied. So that's going to happen in this case. So I just want to focus on the actual test. So let's go back and let's look at the test. Okay, so I'm going to just take this data and let's just go back to just blank worksheet, and let's start from there. Okay, so I got the data into my Desmos, so I want to go ahead and do the test. So very, very easy. You just click on the plus sign, just like in the previous example. Click on inference. And this time, because again, as this is the mean, we're using the t-test. But what's different? Well, now we're not given the summary, like the mean and standard deviation and the sample size. We actually have the data. We just pasted that into Desmos. So all you have to do is just say that you are using list L that you just defined. And then we click on create test. Okay, so we're going to expand the significance test menu. And at this point, we got to decide two things. What is our tails, left, both, or right? And we also have to fill out the value of mu0. Okay, and then we got our answer. Okay, So now, because we wanted to tell if the mean monthly cell phone bill is different, this is both. Okay, so this is going to be two-tailed test. So we don't have to change that. But can we leave mu equals 0 right here? Like, is this okay? No, it's not okay, because you're not testing that the mean was 0. You're testing that the mean was 50.64. So that should go in here. And now you're good. You got everything. So when you click on the three dots, you can see your t-score or the t-test, or the t-test statistic, whatever. This one is not that large, and it's definitely not an outlier. Remember, outliers are anything that's larger than 3. In this case, it's not quite that easy because it's a t-test and it's a t-distribution, but whatever. Look at the p-value. That's really all you have to know. So let's see what was the alpha value. I think it was the same 0.05. Now, how do I know that this number 0.0764, how do I know if it's more than alpha or not? Well, I just subtract alpha. And because I get a positive answer, that means it was more. If it's more, it's not unusual and you are not rejecting. So hopefully you have that on your note cards. And again, do not reject. We don't have evidence. What about the second part of the sentence after the word conclude? Because you're going to have the multiple choice. Some of them will say different, higher, lower. How do I know? Well, what was the claim? Remember, the claim said that it was different now. So here, we must mirror the claim. So if the claim says different, that should be in the conclusion.